Welcome back to BSpice. In this session, we'll focus on heartbeat monitoring, wherein uh, we'll talk about corrosion. This is a series of videos under technology session. So we have already uploaded one video on heartbeat technology, and this is a continuation of this. This is about corrosion and few more to come up. Scale buildup and the equipment availability, and also various other technologies, whichever is in which related to instrumentation. Okay, so let's go with this now. Heartbeat monitoring. See, measuring performance of a device is expected to be very stable over time if it is operated within its intended range of use, as process conditions will have a minimal influence on the sensor components. So the point is, measuring performance of a device is expected to be very stable over time if it is operated within the intended range of use. Okay. However, for particularly challenging process condition, okay, some impact may provide which could influence the performance and reliability of a device. You got it, friends? Yes. So example of such events are this corrosion or maybe abrasion of sensor, the transmitter sensors with dead part, right? The diaphragm, all these. So the occurrence of foam in a tank or buildup on the sensors. So these are the some of the challenging, process scenarios, right? So these events will influence the physical responses of the sensor, isn't it? Yes. So heartbeat technology detects these influences and converts them into easily understandable information, providing process and device insights which can be monitored by a heartbeat monitoring function, which supports in optimizing our process and in predicting maintenance needs. So this is the intro, friends. I hope this is clear, right? Okay. So what actually helps, what the heartbeat does? See, basically the output, the information is very informative, meaning the physical response from the sensor are converted into easily understandable process and device insights. And specific, monitor dedicated device parameters to optimize operation by identifying any anomalies in the process and predicting maintenance needs. So it's informative and it is specific. And of course, it is predictive. Predictive in the sense that it takes measures in a timely manner to avoid any potentially unsafe process condition or device malfunction. And of course, reliable. Increase plant availability by planning maintenance activities exactly when needed and avoiding unplanned shutdown. So now this all the, what do you call the advantages of heartbeat monitoring. Now we'll go into the actual content of this video. Corrosion. As you can see here, this is your flange. Could be a pipeline flange, could be a transmitter flange, right? So the corrosion has happened. So identification of sensor material due to material removal due to corrosion, right? So all corroded here. So what is the impact if the corrosion occurs? Reduce reliability and measuring performance, isn't it? So sensor integrity could be jeopardized if not actions taken, isn't it? So potential negative impact on further process components depending on the material. If it is, what do you call what do you call, if it is a gold plated, of course it can, your diaphragm seal can withstand it. If it is, the material is not selected for that particular application, then it will get corroded in the longer run. So what is the benefits of heartbeat? So it provides an increased reliability and process safety by early, sorry, by early detection of corrosion. Okay, so it reveals the level of sensor degradation, consequently enables maintenance actions to be planned accordingly. So what are the parameters we take for this measurement? You see here, flow measurement. We call it as a heartbeat sensor integrity. This is important. Okay, this is the data they use for this technology. Flow measurement, it's a heartbeat sensor integrity. Okay. So point level, this is level measurement. They consider a fork frequency. Okay, right. This is about the technology. So how it works actually? For flow, heartbeat sensor integrity value, that is HPSI, okay, that represents the relative change of the sensor integrity compared to its reference value from the factory, from the original design. So, as a corrosion occurs, the sensor integrity is affected, okay, thereby the HBSI, meaning the heartbeat sensor integrity value increases. When HBSI value, that is the heartbeat sensor integrity value, exceeds 4%, the meter is with a very high level of confidence no longer fit for purpose and replacement is recommended. Okay. So often HBSI value is monitored to confirm the absence of a wear mechanism in the process. So in that case, HBSI value will remain at a stable low level. So like corrosion, abrasion also removes the material from the sensor and consequently has a comparable effect on the sensor physical response. So this is how we actually measure this, friends. As you can see here, this is the HBSU value. This is the days actually. As the days progress, you see the HP value. It's reaching like that. If it is more than 4% mean, then it's gone. Okay. So that's how, friends. This is just a more of a what do you call informative video for you. If you want to also yeah, use this technology, you can make use of it. So just more of a informative. Thank you for watching. Yeah. Yeah, that's all. See you in the next video wherein we will talk about build up and material compatibility and foam detection. There are many more technologies. Of course, based on your interest, I will start uploading this videos. Thank you. Take care. Bye-bye.